Hi, I'm John Cuthbert, and I'm joined in the studio today by Mr. Robert Gregory, Managing Director of Celsius Resources. Thanks for joining us, Robert.
Thanks for having me.
Now, the world is transitioning to cleaner energy sources and a reduction in carbon emissions. There's been a lot of interest in lithium for batteries, but of course batteries require a lot of cobalt and copper too. Can you tell us why cobalt is so important?
Well, I think if the world's going to achieve zero carbon by 2050, there's going to have to be a lot more batteries out in the world. Nearly every smart device on the planet has lithium batteries. It is going to have to find a way of storing renewable energy in the form of batteries. Cobalt is an important part of the battery world. Cobalt has high thermal stability, high energy density, and what that means is it doesn't overheat and cause a fire. Over 50% of the cobalt use in the world goes to batteries. Because of cobalt's great thermal properties, it is widely used in both lithium and cadmium batteries as the cathode. Therefore, its use in the future will be exponentially increased with the use of batteries.
Now, more than 70% of the global production of cobalt takes place in the Democratic Republic of the Congo, the DRC as it's known. But the use of child labour in the DRC mines has raised question marks over the ethical cost of electrification. Your cobalt project, Opuwo, is in the much more politically stable and regulated Namibia. What's the significance of this?
Yes, you're quite correct. And of that 70% produced from DRC, nearly 90% of it is processed in China. There was a great program on Monday night on Four Corners that highlighted how nearly all end users of critical metals have no idea of the provenance. Just like the big end fashion labels needed to make sure that their products weren't being produced in sweatshops, electric vehicle manufacturers equally need to make sure that all their minerals are being sourced from ethical jurisdictions. BHP announced late last year that it was introducing blockchain technology to track its minerals from cradle to grave. This will mean that cobalt from ethical jurisdictions like Australia and Namibia will be in great demand.
Opuwo appears to be a globally significant cobalt resource, but to date has, I think fair to say, flown under the radar. Tell me about the company's current focus on Opuwo.
Well, Opuwo has a JORC resource of over 225 million tonnes grading at 0.12% cobalt, 0.43% copper and 0.54% zinc. At today's commodity prices, this is more than $30 billion of metal in the ground. The company has an obligation to move this project forward. The best way to achieve this is to de-risk the project by drilling fresh metallurgical core. This drill program is now nearly complete and a number of new metallurgical flow sheets are yet to be tested. We are very excited that this new test work will unlock the cobalt potential at Opuwo.
The company once completed a scoping study but never published it because of insufficient metallurgical data. Now, some have speculated that the cobalt can't be extracted. What's changed?
Well, it's not that the cobalt couldn't be extracted, it was just that the company could never show an economic flow sheet that it could be extracted. The cobalt in Opuwo is finely disseminated, sulfide, and what that means, it's very, very small crystals. Now, most sulfides are concentrated in a process called froth flotation. That's just like blowing bubbles in a milkshake, and the sulfides stick to the bubbles and flow over and all the heavy rock floats to the bottom. In the processing of copper sulfides, for example, you actually upgrade copper grades from about 0.8% up to grades of about 26%. That means that your concentrate that you produce is quite saleable and you can put it on a ship and you can send it around the world. However, in Opuwo, we're upgrading cobalt from grades of 0.12% to grades of only about 2%. The other 98% is pyrite. This concentrate cannot be sold. You need to actually add a refining solution to the back end of the process. As you can see on the screen, the refining solution used in the previous test work is denoted by the red arrows at the bottom. They chose to use pressure oxidation, which uses large quantities of oxygen because of the high pyrite content. This produces a lot of sulfuric acid, which needs to be neutralised, so there's a huge amount of limestone needed to be added. By the time they've got to that point, it was just purely uneconomic. So with the high pyrite content within the concentrate roasting actually is the more preferred route. In this process, the pyrite's your friend and it's an energy source within the process. So at the end, all you're doing is using a calcine leach to get the metals out. This would be a much cheaper option than the pressure oxidation. So we believe that concentrate roasting would work. It would have a reasonably high capex, but it would have very low opex, which is what you need when you're starting with a very low grade concentrate. A more promising flow sheet is using hydrometallurgy, which we plan to test in Australia. In this flow sheet, we use the same bulk concentrate from the flotation circuit, but this time we use a chlorine leach. The chlorine leach will produce hydrogen sulfide gas, which we can then convert to elemental sulfur or sulfuric acid through a standard sulfur plant. Elemental sulfur or sulfuric acid is readily saleable in Namibia because of the uranium industry. In addition to these saleable products, the sulfur plant produces large quantities of energy. It's quite often you have power stations attached to sulfur plants. However, we can use this high energy to then use the acid regeneration at the other side. At high temperatures, the acid can be recycled, which means that the acid is going around and around, and it really reduces your reagent cost. And in addition, the pyrite which is in the system gets precipitated as hematite, and that's again a saleable product. It's iron ore. More importantly, the secondary leach can produce value-added products. Battery companies don't necessarily want cobalt metals, they want cobalt sulfates and the like, and these will actually attract 120% of this cobalt price. More importantly, all these possible flow sheets are borrowed from known commercial technologies. There's plenty of examples of sulfur plants and acid regeneration plants in other industries. What's new in this particular flow sheet is it's cobalt sulfide, because most cobalt comes as byproducts from copper and nickel. So having a unique solution for cobalt sulfide is a bit of a world first. If this flow sheet proves positive, as we believe it will have a much reduced environmental footprint as opposed to roasting. It aligns with investors' increasing focus on ethical and environmental sound source of metals.
Once you de-risk the metallurgy, what is Celsius's plans for Opuwo?
Celsius can't develop two projects at once. The MCB copper project in the Philippines is more advanced and more appropriate for a company the size of Celsius to develop. We've been quite clear in our intentions for Opuwo is to sell, JV or spin off with the right company that can bring the necessary resource and management to bear. We have engaged a corporate advisory group to assist us in this process. Our preference would be to spin off the project because this would give the maximum value to existing Celsius shareholders.
I have a few questions here from our audience. The first one here wishes to know if Opuwo is spun off, what does that mean for Celsius more broadly?
Broadly speaking, it means that the MCB project will be funded all the way through to feasibility. This means we do not have to go back to the market at this low share price.
And the second question here wants to know about when Celsius will be releasing the drill results for MCB.
The drilling's been finished for some time now, and we've been waiting for the assay results from the laboratories in the Philippines. All the laboratories and nearly all services to the mining industry have been affected greatly by COVID. We do expect the results sometime in the next couple of weeks though.
And I'm afraid that's where we need to wrap up this interview. Thank you very much, Robert, for your time and shining a spotlight on Celsius Resources.
Okay, thanks for having me.
I'm John Cuthbert. Until next time, goodbye.